Okay. So hello to everybody who is participating in our MOOC Hangout. Uh, I'm Chris Elliott, Professor of Food Safety at Queen's University Belfast. And at the table, I've got a number of my colleagues here, and I will introduce you as we go through. So, first of all, thank you very much for participating in our MOOC in agri-food systems. It's a subject which has enormous importance and interest worldwide, and because of that, we're absolutely delighted because thousands of people are now studying our MOOC along with you. We've received quite a lot of questions from various people who are taking the course. And what we've done is we have selected a few of those questions, and I will be posing these questions to my colleagues and trying to make life as difficult as possible for them in answering it. So what I'm going to do is, first of all, I'm going to introduce you to Dr. Brian Green, and Brian's 1 week on issues relating to diabetes and metabolic diseases has been completed. So Brian, very welcome to our MOOC Hangout. And what I would like to do is, we got a question from Kathleen Polly. So Kathleen, very, very many thanks for that. And the question is, it's really clear that obesity rates are rising rapidly for both men and women. And Kathleen poses the question, is this because food is more readily available and people are overeating, or is it just a lack of people being able to control impulses to eating, or are there more underlying causes of diabetes worldwide?
Yeah, thanks very much for the question, Chris. And actually, I should say thank you, Kathleen, for the question. It is a really big question, and it's something that I think that health professionals around the world are really grappling with. But the short answer to what's causing the obesity crisis in both men and women relates to the same three things that we relate to for many diseases. And that's to say, our behavior is an aspect of this, the environment in which we live and sit, and the genetic factors that we're comprised of. So all three of those have a contributing effect to the rise in obesity. And I think there's no doubt that human behavior has changed dramatically in the last number of decades, and our attitude to food has changed. And I think quite a lot of you raised comments and questions about just how much human behavior has changed, and our attitudes to food and our values that we associate with food have changed. And also you raised the environment and the types of foods that are available. And indeed, Kathleen's question relates to the fact, just because more food's available, does that mean people are overeating? That's what's leading to the obesity crisis. And she says, is this something to do with control, our lack of control with regard to food and our impulses to eat? And I think that leads us on to some of the genetic factors that might be involved. And I think one of the big theories over the last number of decades around obesity and the rise of obesity is to be something called the thrifty genotype hypothesis. And you've never heard of that before, but you probably have heard of that before. The thrifty genotype hypothesis, that idea that over millions of years of human evolution, we've been exposed to periods of famine, and our bodies have adapted to these by trying to cling on to nutrients and hold on to them and store nutrients and be efficient with those nutrients. And that's what we've evolved through. And our genotype has evolved. Our genes have been selected on the basis that we've survived well under fasting, famine type conditions. So that theory has been permeating through the scientific literature for many years. There are some doubts about this thrifty gene hypothesis, and some of them actually coming up in the discussions that there were in week one. So a lot of people were asking why all these Pacific Island populations have such high levels of obesity. So we were saying that some Caribbean islands and some South Pacific islands have rates of obesity of about 40%, which is even higher than ourselves in westernized developed countries. And they are the exceptions to the rule, and they are what make the thrifty genotype hypothesis so disbelieved, if you like, because the idea for those people would be that they would have had abundant supply of food in the place where they live, plenty of fish and warm waters, plenty of fruit and vegetables available to them, and it wouldn't have been subjected to periods of famine, whereas other parts of the world would have been. So this is the kind of conflict that crops up. I think a lot of people still have a lot of faith in the thrifty gene hypothesis because we've now identified so many genes and gene polymorphisms that are associated with obesity. So I think we've got like 22 gene loci that are now associated with the development of obesity, 22 different genes. I suppose to pick one, there's one called FTO, and it's been nicknamed the fatso gene. They call it the fatso gene, and it's one of the strongly associated ones, where if you have a particular genotype with this gene, you'll gain 3 kilos in weight as a result of just having that particular gene allele, if you like. And the interesting thing is, I think behavior is so important because even if you have these genes, you can wipe this out, because if you have that genotype, they put people on studies and give them periods of exercise, and they can actually virtually eliminate these 3 kilos of extra weight just by putting people on a regular 45 minutes 3 times a week of exercise, and that completely eliminates the weight gain associated with these genes. So it does show us that we have the responsibility and we have the control as individual people, but of course there's lots of drivers around this to do with government and other food industry and other organizations that have a role to play in solving the obesity crisis. So it's a big question. It's difficult to answer because everyone's got their own bigger theories. I think genetic predisposition is important, and what we do as individuals is pretty important. I'll creep back into the environment part of this because, you know, we say we're now living in an obesogenic environment, and our society is an obesogenic environment because high calorie foods are just very easy to come by. We can walk; they're very cheap to buy, relatively speaking to previous years in history. So, I think this idea of environment is very important. What we're exposed to on a regular basis. If it's easy to gain, easy to access, and you're just thinking of convenience all of the time. And indeed, there were a lot of comments about convenience foods, and maybe the food industry should be rethinking their strategy to convenience foods that to make people eat healthier. And you do see some of that now in the food industry, where ready meals are healthier than perhaps they might have been in the past. But still, you see plenty of examples of horrendously calorific foods, cheap and easy to buy. Maybe there's a role to play there in improving the environment aspect of all of this. So that's sort of my answer to the question. I'll try and recap a little bit on what Kathleen posed. So she's asking about the causes of this, and she's asking about control. And to try and bring it all together, there's genetic factors, there are environmental factors, and there's our behavior. And those are the 3 things. We can't do much about our genetics as individuals, but we can do an awful lot about our behavior. And to a certain extent, we can use our behavior to control what environment we're exposed to. So, where we take ourselves on a day-to-day basis, what shops we frequent, what restaurants we frequent, those are within our control, the environment we expose ourselves to. So it's, I suppose the message is, whilst this is rising rapidly around the globe, and yes, there's more government can do, and there's more the food industry can do, we do at the end of the day, I think as a person would say, independent choice for people, that people have a role and it's their choice at the end of the day. So I don't know if that completely answers all of what she's asked, but it's
well, I think that's very, very useful information. Hope that did answer your question, Kathleen. But always when you ask one question, it leads to many more. And I wrote quite a long list down here. So you talked about healthy foods. So quite often I say there's no such thing as a healthy food or an unhealthy food. There is a healthy or unhealthy diet. And maybe would you agree with me on that?
Yes, I think I'd agree with you on that, because I'm not a person who would advocate, restraining yourself on every individual desire. So living a very plain life, everyone likes to have a treat, especially around celebrations and birthdays and so on, what have you. So yes, you will inevitably, encounter foods that are unhealthy, but you have to look in the round, absolutely. So it's what you eat on a week-to-week basis, taking all of your diet into account is important. So yes, I totally agree with that.
And also I think in relation to the advertising of foods, you can see on the label it says healthy. it doesn't mean that it's low in calories, that the two are not always connected.
Yes, so healthy is a fairly vague term. And what aspect is healthy about it? Is it low in salt? Great, but might be high in fat.
Yeah.
Might be low in fat and high in salt, etc. So there's plenty of examples where things are marketed that way.
Just I think to people always be aware of what people how people try to sell you food, and it's more about, I think, what Brian said about really thinking about a balanced diet and so forth. Because if we go back maybe 10 or 15 years, the demon of food was the amount of saturated fat, and there was a huge amount of effort to reduce the amount of saturated fat. Now, whereas it seems over the last 1 or 2 years, the demon is now sugar. Is it as simple as that, Brian?
No, I think the advice has to come back to your idea of a healthy, balanced diet, and it's not as simple as that. So yes, in the past we have demonized saturated fats. To some extent, we've rolled back a little bit, and the evidence hasn't been fully supportive of saturated fat being such a detrimental factor. But it doesn't matter what amount you consume. Sugar is hitting the headlines a huge amount in the last couple of years, and particularly now it's very high level in the media, and there's discussions, at least in the UK, about potentially bringing in sugar taxes to control consumption. But sugar and fat are both sources of energy and calories, and yes, I think if people look at their diet in the round and look at the total number of calories against what they should be consuming, then that would be, my advice would be, we look at everything in the round. So yes, sugar ought to be reduced in our diet, because clearly it's a factor in the development of obesity, as is fat, but it's just the current topic at the moment, sugar, I think.
Okay. I wanted to pose a second question that came from one of our MOOC followers, Josiah. So many thanks for that. And the question, it's an interesting one, because it's not about diabetes, it's about pre-diabetes, which is maybe a new term for many people. So perhaps could you explain to us what pre-diabetes is, and can that be reversed by having a healthier lifestyle?
Okay, yeah. So we'll take this one first. Pre-diabetes is not an officially recognized medical condition. It's believed to be a sort of forerunner to diabetes. So it's what happens in the lead up to diabetes. There are a number of symptoms that are similar to diabetes, but it's not overt diabetes. It would not be classified as diabetes. So we're talking about where blood sugar levels have risen a little bit above what would be typical for the average person in the population, a little bit higher than usual, but not high enough to be diagnostic for diabetes. And there are different criteria for that. So in America, the American Diabetes Association will say, they'll set quite wide targets for that. They'll say anything above 5.6 millimolar up to 6.9 is this pre-diabetic state. The World Health Organization, much more conservative, more stringent target. So it's saying anything above 6.1 millimolar blood glucose to 6.9. So they don't want to overdiagnose. But this pre-diabetic state, higher blood glucose levels than usual, they say that a certain percentage of these people will then go on to develop type 2 diabetes. But that's not necessarily the case. So it's not guaranteed that will happen. It's not the definite lead on to diabetes, but maybe up to 50% of these people with a pre-diabetic state will be going on to develop type 2 diabetes. So I think in the MOOC, we were discussing a study that was conducted, I think, by American Journal of Nutrition, American Journal of Cardiology, which was saying that the rates of pre-diabetes in the Chinese population are rising extremely rapidly. So they did a study of a few thousand Chinese people and saying that there's up to 50% of the Chinese population might have pre-diabetes. Mm-hmm. So it's difficult to interpret that result. It's very, very high. Obviously, it's a population that's changing. They're changing their habits and behavior rapidly. So their blood glucose levels are rising. How many of them might go on to develop type 2 diabetes? If you apply Western studies to these Eastern studies, then you might say, 50% of the pre-diabetic population, that's like 25% of the entire population, will go on to develop type 2 diabetes. So the Chinese government is worried about this, and they think that this is a potential time bomb for them in the future. So it's an indicator. It's not a formal disease as such that we would actively, proactively treat, but it's a condition that is recognized in the research literature. It's not something necessarily your doctor will diagnose you with, but it's a kind of an indicator that you should be concerned that there may be something that you ought to do about it. Just to finish off on this point, which is this, because Josiah did ask about how it's possible to reverse, and I'll give you the guidelines by the American College of Endocrinology. They say healthy meals, a diet low in saturated fat, so it sounds very familiar, low in saturated fat, low in sugar, low in refined carbohydrates, and a limited amount of salt. Okay, so that's a diet. They say physical activity, so we want about 45 minutes a day for 5 days a week. It's quite a bit of exercise, and reducing weight by something like 5 to 10% of your existing weight, and to try and meet the reductions in blood glucose that you'd need. So that's what the official advice by the American organizations would be in relation to pre-diabetes, trying to eliminate it.
Okay, and it actually sounds like pretty good advice to everybody. So Brian, thank you very much for that. We'd love to continue discussing this with you, but we've run out of time on your session. What I would like to do now is introduce our next presenter on the MOOC, which is Professor Aaron Mall. Aaron is a professor of parasitology, and whereas before with Brian we were talking about food and disease, now we're going to be talking about animal health, animal disease. So Aaron, again, a lot of interest in your topic, which will be coming up very soon.
Yes.
And we have already some questions. One is from Brex in the Philippines. Brex, many thanks for that. And it talks about the methods that you will be talking about will be very innovative and no doubt effective. However, it takes a long time before these methods become accessible to everybody, particularly if you're in a developing country. So what's the best way to tackle this in relation to getting these innovations into things that become standard practice?
Okay, thank you, Chris, and thank you for the question, Brex. It is a very interesting question because there is a challenge in shortening the timelines from the discovery of some form of new therapy until it's on the market. And the truth is, for many things, especially those to treat animals and of course humans, because humans suffer from many of the same parasite diseases, it is a long period of time, typically around 15 years from the discovery of the bioactive molecule. Once it goes through all the toxicity, safety tests and getting that formulated and produced, that is a long window. So what you're trying to do from the drugs, for the drugs used to treat animals and humans, is generate a pipeline. So you have a pipeline of new drugs that can come in once the one being used now becomes ineffective, which it will, because one of the take-home messages from the course, where we're looking, of course, at food production from animals and crops, is that where there is a new drug, resistance will develop, and it's not a question of if it will, it's when it will. So that is the issue and the driver for bringing forward the new drugs. So what we've talked about in the course, certainly one part of the course focuses on the use of functional genomics, reverse genetic techniques, which knock out genes in target organisms. And if we're trying to do that in animals, that will take some time. There are some therapies coming through in human medicine for eye diseases. But for the treatment of pathogens in humans, I would say that's probably at least a decade off. However, for the treatment of parasites of plants, we already have them in crops. Some crops in the US, where they have generated crops which are triggering a process which switches off a gene in a pathogen. So the pathogen comes in, the switch comes from the plant to say, turn that off, and the pathogen needs that to live, and the pathogen dies, whether that's a worm parasite or a corn borer in this instance. So in terms of plant technology, it's about 6-7 years, human, animal, 15 years. So that is a real issue, Brex.
Thanks very much for that, Aaron. I mean, I think it's very clear from discovery of a molecule to have it that farmers can use is a very long period of time. And I mean, are you optimistic about the future? Because a lot of what I read about is growing problems of resistance to the drugs that we have relied on for the last 10, 20 years?
Um, I'm certainly confident that we can generate the molecules to treat these where there's a will, and that's always the key. There's been an evolution in our understanding, because what really has happened is we went towards intensification, and what intensification does is it enhances the impact of the parasites. Once you have more animals closer together, potentially more stress in those conditions, they're more susceptible to parasite infection. The parasite loads get higher. Concentration of parasites in the pastures goes up. Disease becomes more important because the production is lost, and potentially animals are lost to that. So in that context, it has clearly been an evolution from non-intensive farming to intensive farming, where we learned about resistance. So we've generated the drugs in the past. They've been excellent drugs, and they've kept the worms, the parasites, at bay for a long period of time. But as we've repeated the use of those, as is with the problem with antibiotics, we've generated populations of parasites that are no longer responsive to those drugs, and therefore we can no longer treat them. Now that we've kind of learned that, I think the processes are in place now where certainly the major pharma for veterinary medicine are putting in place programs to generate bioactive molecules that are active against these parasites, to try and have a pipeline. So when that one fails, we have another one to plug in. That's an ongoing process.
So I'm going to move on to another question that came from one of our MOOC followers, is Lorna O'Leary. So Lorna, thank you very much. And it's in relation to neuropeptide signaling. And Lorna says this sounds very exciting. Her question is, what about the delivery of these types of drugs? Can we be sure the drug is being delivered to the parasite without affecting the host?
Okay, well, thank you for that question, Lorna. I'll just give a little bit of context for the other listeners right now, because neuropeptides is a term that's just suddenly been, will be new to many of you, I'm sure. Basically, the control of parasites is relied mainly on drugs, a relatively small body of broad spectrum drugs that kill lots of different worm parasites typically. And if you look at most of these, what most of these do is they compromise the ability of the parasites to move or coordinate where they go. So it works on what we would call their sensory or motor systems. So they can basically don't behave normally because they can't, because you've disrupted it with active molecules that act on their nerves or on their muscles. Most of the drugs have targeted what we would call classical transmitters, and you might have heard of some of these: acetylcholine, GABA. We have them in our body, so do these parasites. And we've had drugs that compromise those signaling systems in the parasites, and they've worked great. A whole area of signaling inside the worms that has never been targeted is neuropeptide based, basically a larger signaling molecule that comes from very small proteins. So what we know is these are also essential to how these parasites move and sense their environment. So in that context, there's a whole raft of new drug targets that have yet to be exploited, and that's why we're highlighting that. Now, one of the very attractive things of the neuropeptide system is the fact that although they have neuropeptides and we have neuropeptides, theirs are very different. So drugs that target their neuropeptide signaling system, which would typically target their receptors for their neuropeptides, would be structurally different and would lower any chances of toxicity in the host. So you would give a drug that would act on the worm selectively. Okay. Most of the drugs now work on the classical systems, and there is this risk, or has been previously, if you tackle an acetylcholine receptor in a worm, there's potential for cross-reactivity with acetylcholine receptors that we need to survive. So that would enhance the risk of toxicity. In this case, we're looking at systems that are unique to the parasite, hopefully avoiding this risk of toxicity. But as with all drugs, there would be very serious efforts to check the toxicity through a wide range of experiments over a long number of years to establish that before any drugs were launched.
Thanks very much.
Okay.
So now to make life difficult for you, okay? So let's say in relation to mankind who are fighting parasitic disease, mankind has been on the planet for a very short period of time. compared to the organisms that you're fighting. They are smart. They can adapt much more quickly than humans can. Who's going to win the war?
Well, ultimately, what we strive to do is to minimize the impact of pathogens. I think it would be foolish to say we can wipe pathogens off the planet. We can't. They do evolve fast, and they do evolve faster than us. But the interesting thing about this is we have actually evolved with them. And I'm going to turn it around slightly in one aspect just to highlight the point. And that is, we have evolved with many of these pathogens in us. Most of our forebears had, believe it or not, worms in their guts. We've got rid of them. We live in environments, most of us, where the water is filtered, where we're not getting these worms in our guts. And there is this hygiene hypothesis, which is a lot of compelling data supporting it, that what that has led to is weaker immune systems. Our immune systems are not being challenged like they have evolved to be. And therefore, we certainly in the developed world are far more prone to things like autoimmune diseases, ulcerative colitis, Crohn's disease. And yet you look in places where there still are these worm infections, they're literally non-existent, these diseases. So there's a lot of thought that because the parasites come in and modify the immune system, we have grown used to that. And I suppose potentially we have to evolve for some period of time without that to try and reduce the negative consequences of living without them. Having said that, I'm not condoning everyone gets infected with pathogens, because obviously quite often a small number of pathogens doesn't do much harm, but a lot of pathogens will cause pathology, serious disease, and potentially kill animals, plants, and humans. So in that context, it will be a running battle, and it will continue, because it's a wee bit like the Red Queen hypothesis. We just have to keep adapting our methods to try and keep them at bay, and we have to get smarter faster. And I will say, like the antibiotics ball, the anti-parasitic ball was dropped by us, in that we've got brilliant drugs, we can relax those efforts, and then we get into the pickle that we're in now, and that we don't have enough new drugs in the pipeline.
Okay, thanks for that. I also suggest that the hygiene hypothesis may also play a role in diabetes, because a lot of what I read about now is it's about the complete change of the microbiome in our guts. It affects how we deal with many, many different things. So do you think there's any potential for those two subjects, which a lot of people will think there's no link with, the hygiene hypothesis links them together?
There are some parts that we could talk about which are linked to directly causing diabetes, but in a different context. But in this context, no, I think absolutely that the parasites are modifying the physiology of the gut environment, the physiology of what's taken into the blood, the level of nutrients in the blood. So in many different ways, they could impact your transition towards a diabetic state. I have absolutely no doubt that is the case. I don't think there's much data to support it, compelling data right now, but I think, again, it would be foolish to say it's not possible. Of course it is.
Okay. If I could just come in on that one, because the hygiene hypothesis has been linked not to type 2 diabetes, but to type 1 diabetes. So yes, we're seeing rises in the rates of people with this obesity-associated diabetes, but also the other form that develops young type 1 diabetes is related to the hygiene hypothesis, and it's an autoimmune disorder to do with modulation of the immune system, and they think that perhaps part of that has been to do with our very clean environment in which we live, houses with central heating and so on, as contributing effect to the development of type 1 diabetes, why it's rising, because we could not explain otherwise why type 1 diabetes is rising so much.
Okay, so just to summarize what our first two lectures have said is, eat less sugar and eat more worms. And that is a joke. Please don't eat more worms. Okay. A very final question for you, Aaron, is that if you think about parasitology on a global basis, which do you think is the biggest concern? If you want our listeners to read about one particular type of parasite, is it river blindness? What do you think is having the biggest impact on mankind globally?
The parasites which are affecting man are slightly different in species names from those that are the most impactful on animals, and obviously quite different from those in plants. So if I was to focus on man, it's a close call between the blood fluke, which affects the most people, causing very serious pathology, and I would say lymphatic filariasis simply because of the amount of disability that occurs. It's the second biggest cause of disability worldwide after head trauma, which is quite remarkable. So in terms of scale, I would certainly put blood fluke parasites and schistosomes at the top of the worm type parasites that can also affect animals. But obviously, if we were looking differently at parasites that have a selective problem in humans, we would pick malaria. Malaria still kills, you know, a child every minute or so.
Okay, Aaron, thanks very much.
Okay.
Again, it would be good to continue the conversation, but
Absolutely.
we've run
Thank
out
you.
of our time with
Thank
you.
you,
So
Chris.
now I'm going to move on to Dr. Niamh O'Connell, who leads the animal welfare work at Queen's University Belfast, a very important subject. But first of all, I wanted to ask you, Niamh, a question that was posted onto our Hangout page, which is quite general actually, and it says, what can we do to tackle the food crisis situation? So what's your take up on that?
Thanks, Chris, and thanks for the question as well. It is a very broad question, difficult one to answer. I think I'd probably start with the obvious, and I think something that's not often discussed, but I think the first step is to value our farmers and our farming community. We need our primary food producers, and as I said, it's an obvious point, but sometimes neglected in this whole debate. Within developed countries, we have an aging farming population. We need to make farming an attractive career for young people entering the market. We need to make it a stable career. We need to make it a career that allows them to support a family. So I think that is important, and how we address that, I'm not sure. Perhaps it comes down to economics and the amount of margin that they receive for the products they produce. Perhaps it's level of control and level of interaction with the end consumer. Perhaps it's the bureaucracy that surrounds farming, but it does need to be a more attractive job for new recruits into the industry. I think that's important in the developed world. I think in the developing country, in the developing country and world, there are other challenges for small scale farmers. We need to ensure that our research into renewable technologies, into any of the different technological aspects of farming reaches them. We need to try to support developments in infrastructure so that those small scale producers in developing countries can reach markets. And we need to look at credit and finance to support them as well. So I think the approach is going to be different depending on where these farmers are based, but I think it is important to really support and value our food producers. And I think that's a key point in moving forward in the global food crisis. I think we then also need to move to the thorny subject of considering the food that we actually produce. And there's a good quote in one of the articles I was reading recently that says, you know, what we eat, and it's come up in this discussion, affects not only our health, but it affects the health of the planet. And I think there's a growing awareness that we are going to have to consider alternative protein sources. And I think we're going to have to open our minds to alternative protein sources, be they insect or plant-based. And I think that is likely to happen. I think, again, if anybody talks about agriculture now, often in the same breath, they talk about precision technology. So we need to think about the food that we are producing and also how we're producing it. Obviously, it has to be as efficient and as energy efficient as possible as we move forward over the coming decades. And people often talk about precision technology in terms of, you know, machinery and satellite technology and smart apps, etc. And that's all really, really important. But it's much deeper than that. I mean, precision technology or precision agriculture involves ensuring that the nutrients that you feed animals actually are exactly what they need to maximize their performance and their health and their welfare, that it really is targeted to the animal's needs. And I think there's still a lot of work to be done in that area. So we have to consider the food we produce and how we produce it. And then we have to move to how we consume food in terms of tackling this crisis. And we've talked again about how economic growth leads to an overconsumption of calories. You know, we don't need those calories in most developed countries. We don't need that level of consumption of calories. So we have to consider that. And obviously government strategies are important here and government initiatives in relation to that. We have to talk about wastage. There's a statistic that I came across recently that 33% of agricultural productivity is wasted. Mm-hmm. So you know, in terms of solving a crisis, there's an obvious no-brainer to start with. And then again, and it's a constant issue that I come across and that I raise a lot, is that we have to re-engage with food production as consumers. We need to start to understand again how food is produced, and to connect again. We have become separated from primary food production, and we don't really, many of us, understand now where food comes from and how it's produced and the implications of those production practices in the whole global food crisis. So I think there are education initiatives that need to happen to help people to reconnect and understand better the implications of what they're buying. So yeah, they're the key areas that I would focus on in terms of tackling the crisis.
I mean, thanks for that. I mean, you've covered so many different subjects there, and I think it shows the complexity of what we're dealing with here. It's very interesting because you talked about the farmer, because rarely do you hear actually food is produced by farmers. Mm-hmm. Now, here's a question for you, Niamh. What's the average age of a farmer in Ireland?
Ooh, I would imagine in their 50s.
57 years old is the average age of a farmer now in Ireland. In Japan, the average age of a farmer is 60 years old. Mm-hmm. The movement is about the depopulation of the rural areas. People are moving into towns and cities to have a better livelihood. Mm-hmm. And that's what's happening. So a lot about what you talked about there was valuing farmers and so forth. But then you're into the great complexities of global food supply systems and global supply chains. It's enormously complicated.
It's very complicated.
Yes. And the other factor, you know, if I was marking your homework there, I would give you 9 out of 10. I think the other big driver on food crisis is climate change, something that's out of our control. Mm-hmm. So there's so many different things there. But in relation to your own area of research, which was very much about animal welfare, how do you think animal welfare, or poor animal welfare in particular, is a contributor to our food crisis globally?
It depends on your perception. It might help people, because my section hasn't run yet, if I just briefly go through what I talked about as part of my
free advert for you, everybody. Okay.
As part of my week within MOOC. And really my section was dealt primarily with intensive livestock production and the animal welfare implications of it. I think if animal welfare is important to consumers, then it is an integral element in this discussion about moving forward with livestock production. And in most cases, when consumers are interviewed, they will express concern about farm animal welfare standards and express the fact that it matters to them. Now, I'll move on later to discuss why that might not always translate into behavior at the checkout, but it does seem to matter to consumers. So in terms of moving forward and addressing the global food crisis, to my mind, animal welfare has to be a central component in amongst all the others that have to be considered in relation to food safety, environmental factors, etc. So my definition of intensive livestock production is large-scale production where there is a very significant focus on efficiency of production and on productivity. So my definition might be different to some other people's definition. I don't classify it as being indoors or outdoors. I classify it in terms of the focus on productivity and efficiency of production. So I would classify some free range systems as falling within the scope of intensive livestock production. And within the section, I talk about the ways in which this productivity and efficiency of production is maximized. So through genetic selection approaches, through animal nutrition, and through environmental factors. And then move on to talk about some of the implications for farm animal welfare. And there are implications, and there's been a lot of survey work to show there's problems in terms of levels of lameness and aggression and harmful social behaviors, in addition to the health issues that were also discussed. So, and this is why I think this conversation is so timely, because in the presentation, I would have talked about the drivers that have led us to this point and this type of farming. And we're now at a crossroads where we need to look at the direction we're going in. We still have these drivers for increased intensification. Climate change issues are one of them. Environmental pollution of soils and waterways, another issue. growing populations. There are key drivers that are moving us down a road of increased intensification. But given the problems that already exist within our systems, we need to take a step back and ask, well, how is this intensification going to happen? I do think there will be a move towards other protein sources, but I think still intensive livestock production will continue. So I think it's really important in this whole debate, and we have to now start asking, well, how can we ensure that the problems we've faced to date become reduced and don't become exacerbated as we move forward and try to feed this growing population. So some of the areas that I would suggest are important, and I, as a scientist, I'm always going to, suggest that science is important, but I really think at a fundamental level, we still have very little understanding of the subjective experiences of animals. We still don't truly understand the level of suffering associated with something like a broken bone versus something like being in a small cage. We still don't truly understand which of those is more important to the animal. And I think that is really important. So I think I think we also need more support for producers. So we have a lot of legislation. We're likely to see more animal welfare legislation, and it is important. But along with that legislation, we need guidance for farmers. And one of the issues that I raise in my week is the fact that we have now moved within Europe from traditional battery cage systems for laying hens to more open systems. These may be either larger cages or they may be free-range systems. And what we seem to have done is swapped one set of animal welfare problems in a cage for another set of problems in free-range systems. So while you have confinement and you have frustration and you perhaps have stress within the cage systems, you have more mortality, more broken bones, more health issues within open systems. So if we are going to have legislation which is moving us more towards less confined systems, then we need really strong guidelines to go with these to help producers manage them to maximize the welfare of the animals. And then I think the final point in this whole debate, which is central to the debate, again, is back to consumers. And if animal welfare is really important to them, then understanding how we can sort of harness that desire into a willingness to pay more for the food and translate that into actual behavior at the checkout. Because what a lot of the research would suggest is a very small increase in product price, even in the region of 1%, if that's passed back to prime producers, could have a very significant impact on welfare standards on the farms. So we need to understand, because any of the research that I have seen will show that there's a strong willingness among the public to buy high welfare food, and there's a willingness to pay more for it. But it just isn't translating into behavior. And I really think we need to understand why that is the case. Is it a labeling issue? Is there a misinterpretation of labeling? Is it a lack of understanding of farming systems and what the real issues might be? So there are a number of potential factors that we need to understand, or to explain perhaps why this willingness to pay more isn't being harnessed. Because I think of many of the factors, that probably has the most potential to yield quite large differences in welfare standards moving forward.
I mean, you covered the area and the importance of animal welfare really well there. And again, there's so many different issues that sit in behind it. It's not just about having happy chickens. There's a lot of things. I also think, Niamh, that if you think about animal health, which is really important, but you also think as part of animal health is animal welfare, because animals with a good standard of welfare are better able to fight and prevent disease. And I don't think that is probably very well known around farming community. Would you think that that's a fair comment? I
think most farmers would be aware, but maybe among the wider community, perhaps that relationship between stress and immunosuppression maybe isn't as clear. But a lot of farmers would probably know that animals that are less stressed are less likely to be to suffer from ill health. But yet it is a very valid point. If we improve animal welfare standards, we're also likely to see improvements in health. And that really is the basis of why some people who are very persistent buyers of high welfare products, one of the reasons is that they see that link between the animal's welfare, the animal's health, and their own health subsequently.
Thanks. And I think there's two ways we can think about changing people's buying habits. One of them, you talked about legislation. So you can legislate for things. What we're told about in Europe, we have the strongest legislation for animal welfare in the world. A lot of our farming industry would say that puts us at an economic disadvantage with competitors. But I think the other thing that you talked about is about how do you promote animal welfare friendly food? Because if you pick up a food package, there's actually, in the food industry talks about real estate. There's very little room on food packages to actually say it's animal welfare friendly, and you're competing with, is it organic? Is it local? Is it fair trade? So, I mean, for both of those things, do you think more draconian legislation worldwide is the answer, or better education?
Better education, I think. And it is difficult for consumers. I mean, often they have a lot of ethical decisions to make at the checkout in relation to environmental, food safety, animal welfare issues. But yeah, I think education is the key to help them fully understand and look for the information that they need to make a valid decision.
Okay. So Niamh, thank you very much. I realise that Niamh has to now go and teach some of our students at the university. So we're very grateful for your participating, okay? And I hope your class goes very well. Okay. So what I would like to do now is introduce the last of our panel. That's Professor Paulo Prodal. And Paulo is Professor of Genetics at Queen's University. So Paulo, you're very welcome to join our MOOC Hangout. Again, your topic is live at the moment, so I hope all of those people who are participating in the Hangout are avidly following all of your lectures, Paulo, because again, it's a very, very important and interesting topic. So can I maybe just deal with a couple of questions that have been posted? The first came from Kerry Mortimer. Kerry, thank you very much for that. So what Kerry says, in addition to genetics, what other factors can affect the biocomplexity of species, and how are these relevant to sustainable fisheries?
Thank you, Chris. Thank you also, Kerry, for the very interesting question. Indeed, your question emphasizes the multidisciplinary nature of fishery sciences, and again, the best way to start, I guess, would be from a general perspective. Say the main aim of biocomplexity is to understand how living things interact with and affect the environment and each other. In addition to genetics, biocomplexity research include other areas such as biology, chemistry, oceanography, geology, microbiology, and ecology. The science of biocomplexity seeks to a quantitative and integrative approach towards a better understanding of the complex interactions of the components linked to these different areas of research. Now, among some of the interesting questions related to or underlying biocomplexity and linked to fisheries are, for instance, how exploited species respond and adapt to stress. Can we predict biological adaptation in a changing environment? How climate change affects the geographic distribution of species across multiple trophic levels? Can we forecast the combined effects of climatic and socioeconomic change? How does species genetic and cultural diversity affect system sustainability? Again, I can give you a very simple example in fisheries. We know, for instance, that overexploitation has been shown to drastically affect important population parameters, including, for instance, the number of breeding individuals, size and age at sexual maturity, and fecundity. The knowledge of these parameters are crucial for basically implementing quotas, fishing quotas. I mean, any alteration of those parameters obviously will have profound consequences in what can actually be taken out of a particular fishery. Now, to resume, I guess, biocomplexity is a very important multidisciplinary science. The understanding of which is certainly fundamental to ensure proper sustainable management of fisheries. Consequently, the topic is very high in the agenda of governments on a worldwide scale.
Okay. Well, thanks very much for that. Maybe could I ask a little bit about the consumption of fish? So first of all, many people perceive it to be a very healthy option, but the world's oceans, the seas, we're running out of fish. So I think the statistic now is probably more than 50% of all of the fish we eat globally comes from aquaculture as opposed to wild caught fish. So do you think that trend is going to continue even more?
Very much so. I mean, taking into consideration, as you just mentioned, that most marine fisheries are already heavily overexploited, depleted, or at their limit of exploitation. In order to meet the increase in demand in, say, fish-derived protein, the aquaculture industry will have to expand significantly over the next few years. So,
do you think that creates a lot of opportunity also, because we talked about farmers? Quite often people don't think about people in fishing as being farmers, but do you think there's a potential there for actually creating and growing an industry that will mean that people will want to participate in it?
Oh, very much so. I mean, the potential of the aquaculture industry is actually huge. I mean, I think that links to another question, which was actually presented by another of the students that attended the MOOC there, Andy Boyne. I mean, he actually says the balance in here that we have to take in consideration. I mean, Andy actually asked a question. I've heard many criticism about aquaculture related, for instance, to the impact of escapes on wild populations, the spread of disease, genetic introgression, the use of antibiotics and pollution. According to Andy, he thinks that we are messing once more with nature without really understanding what's going on. So he asks whether aquaculture is generally guided by need. Again, it links to your question, or financial interest in there. Again, going back to some of the points you alluded to previously, there as a direct consequence of population growth, fish consumption on a world scale has doubled over the past 50 years. And indeed, predictions indicate that seafood provision will need to double over the next 10, 20 years if we are to keep up with the increasing demand, which is being driven by rising population numbers and also the high income levels of developing countries. So there is an expectation they should all be having access to fish-derived protein. Now, again, as I just mentioned, if we consider that most marine fisheries are already heavily exploited, or at least at their limit in terms of exploitation, they are not, fisheries, natural fisheries, not going to be able to keep on this type of demand there. So the current thinking is that this could lead to a significant gap in terms of food provision, unless the aquaculture industry raises up to meet the challenge. So there is huge opportunities in there. So the question in relation to what Andy asked there, if there is a need for it, yes, most definitely there is a need for the development of the aquaculture industry there. Now, reflecting on this need, at the global level, again, the aquaculture industry is going faster than any other means of animal food production. This is a fact. Indeed, worldwide aquaculture production, again, is expected to is actually growing on a rate of about 5% a year now. And it is expected that within the next 10 years, we will be providing some of the 40% of all fish-derived protein for human consumption. And I'm not even mentioning animal consumption, because a lot of this material is actually used feed in agriculture or for animal feed, basically. To give an example, how things are developing in Asia, for instance, freshwater aquaculture now is beginning to replace the northern seas as the main source of seafood-derived products. So there is a trend which is actually being driven from Asia, and we will have to catch up with that. Again, as we've learned over the past week, and again, there'll be a few more lectures on that over the next few days, aquaculture is not without problem. There are many issues which are linked to aquaculture. We're talking about pollution, we're talking about the spread of disease, interactions with wild fish. But again, there are ways out. Say modern research is actually raising to meet those challenges. Here we discuss how genetics can be effectively used not only to monitor wild stocks for wild fisheries, so that we can, on a year after year basis, come up with proper manageable quotas in terms of what can be taken from the fisheries, ensuring long-term sustainability. In the other end, we're actually using selective breeding to ensure that we have best fish for aquaculture production. Here we're talking about fast growth rate, we're talking about monosex culture, so increased growth rate, better food conversion using genetics to guide nutrition programs. So it goes in parallel, whereby a lot of research is going to developing the best type of food for aquaculture. Say one of the problems for aquaculture industry currently, for instance, is the fact it heavily relies on fish-derived proteins. And again, so those two things don't necessarily go together. If the point of aquaculture is to minimize the impact on wild fisheries, so we require wild fisheries to feed the aquaculture industry. So the way around, obviously, is to focus most research into nutrition, alternative source of protein that can be reliably used as fish feed in aquaculture program. And again, genetics has been used to guide this type of research, as identifying those individuals which have the best conversion factors, and they can be used as broodstock for subsequent generations, i.e. get into the process of domestication. And so there is a lot of opportunities in there. Other concerns with regards to environmental impact, there has been a lot of research and interesting development in the field of aquaponics. So we are basically talking about a fully recyclable system where everything that's produced in aquaculture is actually reused. Say you're talking about the concerns about food waste or fish waste, being the waste being used as compound to fertilize soil, or say plant filtration systems. Algae in Ireland, for instance, duckweed has been successfully actually been currently assessed as a potential natural filtering system to absorb ammonia, which is one of the undesirable side effects of aquaculture. The algae can break ammonia into nitrates, which are again very good for in terms of compound, and the duckweed itself can be used as a source for biofuel. So the whole process is actually coming together to minimize the environmental impact and maximize throughput. Again, there is a lot of interest from private industry in this particular sector. Again, it's moving from East Asia and into Europe now. Let me say this project on duckweed basically is actually taking place in Ireland.
Okay. So, Paulo, thank you very much for that. Again, aquaculture, you've told us, it is one of the ways that we will hope to deal with the global food crisis. Incredibly important, and aquaculture plays a massive role in that. So thank you very much, and thank you much to all of my colleagues for those really interesting discussions. I hope you've enjoyed our MOOC hangout, and maybe you can see that whenever scientists get around a table together and we start to talk, we get incredibly interested in each other's subjects. And I hope you're equally interested in all of the material that you have learned so far and will take for the rest of the MOOC. Just before we close, I would like to make one request to all of you, is that as a university, Queen's University, we are going to develop what we call a distance learning program. So the MOOCs was our introduction to this, and we will be introducing courses that will allow people to get certificates, diplomas, and even master's degrees. What we would very much appreciate from you is very soon after the end of this course, you're going to get an email with a questionnaire. And I know in your email box, you probably get lots of people to ask you to complete questionnaires. This one will only take you a couple of minutes to do, and we would be really grateful if you could feedback to us about what you think the most important things to you would be in relation to distance learning. So with that, what we will all say is goodbye from Queen's University Belfast. We hope you've enjoyed our MOOC hangout and hope you enjoy the rest of our course. Goodbye.
Goodbye.
Bye.